The exponential function f is defined by f of x equals ab to the x, so the typical exponential function formula, where a and b are positive constants, very important. The table gives the values f of x at selected values of x, which of the following statement is true. So usually when I see this, I often think, oh, okay, I need to come up with a formula, and maybe I will. Maybe I will, maybe I will. Now, this is a no calculator section, so I'm not going to pick up a calculator to do this. And if you're wondering, how is this guy going to do it? How is he going to do it? Well, let's find the pattern. Okay, the pattern here gives you our b. And it looks like the way I get from 3/4 to 3/2 to 3 to 6 to 2 is I multiply 2 every time. So what I have is f of x equals some number, a, I don't know it yet, times 2 to the x power. Now, the way I find out what this initial guy is if I were to substitute 0 in for 2, this whole thing would become 1. So common sense would tell me that if I plug in 0, whatever it is times 1 gives me my answer. I got 3/4. So if I do 3/4 here, then when I plug in 0 to x, 3/4 is going to be my answer. Okay, so again, if you're not sure what I did, the way I find my b is what I multiply to get from one number to the next. The way I find my a is what is my f of x value when x is 0. So let's take a look at what we have, because here it's not asking for the formula, it's asking me for facts about the formula. And it wants to know what's going on where I have a positive a, so all of these have a positive a. Makes sense, it has to be if it's going to be increasing. 2 to the x power implies that b is not in between 0 and 1. It is bigger than 1. It's not in between 0 and 1, and it is bigger than 1. Now, is this growth or decay? Well, if this guy is increasing, I think it's going to be growth. Now, it would be decay here if this number is in between 0 and 1. That's not what I have. It's bigger than 2, which means every single time I multiply by 2, I multiply by 2, I multiply by 2. That is exponential growth, and D is my answer.